Okay, so this is the first video in a series that I'm going to start creating to firstly just help myself understand these concepts that I'm learning better because I think learning through telling someone is probably one of the best ways to learn, especially because it starts to uncover a lot of holes in understanding. So, yeah, to become a better front end developer, I've decided to really understand the fundamentals that form the basis of how the web works, how the internet works, how networks work, because everything that we build as front end developers in terms of web applications are all built for the browsers, for web browsers, and web browsers operate on the internet, and the internet operates on the network. So starting at the network level to me sounded like the best place for me to really start to deepen my fundamental understanding, to then go up from there. So this first video is about the OSI model, and I've used the network factory analogy to really just understand and explain how the network works. In terms of the OSI model, there's a TCP IP model, which I will also make a video of. It's a little bit different, but primarily, it is fundamentally the same. It's just kind of explained differently. So the basically the when it comes to the network, so previous to networking, if you wanted to send data across the world, you have to send a letter in the mail, for example, and that could take weeks, months to arrive. Now we have networks. Our computers can connect to networks, whether that's a kind of internal network, like for example, in computers in an office, or networks over the internet. So I can connect, in London with a computer in New York. Networks allow us to our computers to communicate with each other, and very very quickly. So previously on the network, the wires we used were mainly copper based in my understanding. But now the majority of wires are fiber optic, and fiber optic transmits the data via light. So everything is transmitted in bits, binary code. So if the light's on, it's a one. If the lights are off, it's zero. I know this is probably very basic way of understanding, but because it's light, it's able to travel at the speed of light. Well, not quite, but kind of at a constant of the speed of light, which means that we can, it's completely changed how we can use data in our world. So the network factory. So for if there's a browser, obviously there are many different clients that use the network. But as a web developer, I'm focusing on browsers. Obviously, there are also, for example, email clients that use the network and use the internet. But as I'm a front-end developer, I'm really trying to understand how it relates to web development. So imagine there is a browser who is this client, because they're already talking to the network factory. So this network factory model is basically kind of goes through all of the stages of the OSI model until the data is transmitted via the network. So the the layer 7 is actually the first layer that a client which is, say an application, for example, a web browser, will go through to actually start to access the network, which is why we start here and we go all the way through to team 1, which is the last layer that a piece of data has to go through to therefore then just be transmitted through the network. So a really nice little, I think it's called a mnemonic, that I came across in my learning was this one, which is: a priest saw two nuns doing push-ups, to remember the order of the layers that the piece of data goes through. I'll also kind of add a few little kind of graphics that I've created to help me just further understand in the links. And it's just basically a priest seeing two nuns doing push-ups. So the A stands for application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So team 7, application layer. So a client, say a browser, wants to, for example, send a GET request to a server that is in New York, and this client, say, is in London. So it needs to use a network to actually communicate with that server and to send that data, which is the GET request, to the server. So it enters the network factory and speaks to the first team, which is team 7, the application team. So in the OSI model, the application team is basically the interface that allows the client of the network to actually start to communicate with the network. So it basically is kind of like the call center. The client comes in and says, I have this piece of data that I'd like to transmit via the network. Hello, basically. So it's basically responsible for the direct communication between the network and the client application that wants to use the network. So it is basically, for example, a web browser in this situation. Then once that initial communication has been done via the interface, and obviously on all of these layers, there are protocols that exist. The main protocols that we're going to talk through are on the transport layer and the network layer, but there are protocols that exist across all the layers, and protocols are basically just rules or standards that determine how data is transmitted and through the network, and how the computers communicate via the network. So team 6, the presentation layer. So the data is then sent to is passed to the presentation layer, and this team 6, the presentation team, is responsible for basically getting the data ready to be sent via the network, because the protocols on this layer basically are responsible for formatting the data to make sure that it's compliant with the way that the data needs to be formatted to be successfully transmitted via the network. So the things that will happen to this data at this stage are encryption, encoding, and compressing, things like that. So, for example, different keyboards on different devices are just encoded differently. So we'll standardize it and make sure that it's all following the same standard, basically. Once team 6 presentation team is done, the data then gets sent down to team 5, which is the session team. We've got this little conductor here. So the session team is basically responsible for the sessions that are needed through which the data is sent. So the session team opens and closes sessions, but also maintains the functionality of the sessions when open to allow for successful transmission of the data. It can also be potentially responsible for creating checkpoints, so that, for example, if data is lost, it can go back to the checkpoint and continue transmission from there. And it will eventually close the session once the data has been sent. Okay, and then the team 4 is the transport team. So this team is basically responsible for deciding on the protocol that is used to transport the data. So the main two protocols that are used are TCP or UDP. TCP stands for Transmission Control Protocol. UDP stands for User Datagram Protocol. So if you are a web browser, you'll probably want to use TCP because it's reliable, all the packets are received, the lost packets are retransmitted, the packets will arrive in order. And so this is a connection-oriented protocol where there's end-to-end connection between the two devices that are communicating. However, if you are, say, streaming media like a game or a video, you might want to go with UDP because it can be unreliable. All the packets are not always received, and they might not be received in order. And there might be some lost packets that are not, and lost packets aren't retransmitted because it's just kind of, that's not what the UDP that's not what UDP protocol does. So if you are okay with losing some packets and they need to arrive in order, you'll go with UDP because it doesn't require a three-way handshake, which is what happens at the beginning when a connection is established between client and server, which does increase latency because it's, increases the round trips that need to be done before any data is transmitted. Whereas TCP, you will use if you're a web browser because you want all the packets to be received in order and any lost packets retransmitted. So you're willing to take on that increased latency to get the increased reliability. So once that team has decided on the protocol, the data will be sent to the network team. So the network team is basically responsible for where is this data going and how is it going to get there. So it's responsible for the on this layer in this team for the internet protocol. So the internet protocol is basically every single device that's on the network has a unique address. Static, if for example you're a server, you don't want the address to change, but dynamic, usually or often if you're a client, because the addresses can change, it doesn't really affect anything. So this is the address of that specific computer on the network, in order to make sure that this data is going to the right computer in this kind of network of billions of computers. And this network team is also responsible for sub-networks, routing and switching, basically just making sure that there's a path for the data to be sent to the specific address. Once that's done, then team 2, the data link team layer, takes over, and they're basically just like a traffic controller. They're responsible for error control, media access control, and other responsibilities to make sure that the network is basically running as it should be. There are no pileups, and the data that needs to be sent is getting the access that it needs to the network, and it's completely unbiased. It's just like a board, unbiased board that is making these decisions and keeping everything running smoothly. And so once that's done, then team 1 can take over the physical team. So the data is sent down to the physical team, and this is basically the team where all of the hardware that makes the network up the network is. So it's everything that you can see if you looked into and at a network. So all the cables, the hubs, etc. So at this point, the data is in the correct format. It's been run through the correct protocols. It's in the correct format. It has all of the right. It's been destructured in the right way, and it can just be sent out onto the network and to its recipient device. So that's basically the OSI model in terms of the network. Yeah, I think that's pretty much sums it up. I'll do another video about the TCP/IP model because it's a little different. It's only 4 layers and it doesn't really pay much attention to the lower levels, like the physical layer, for example. And some of these layers are kind of combined into one layer. So I will do another video about the TCP/IP model, but in terms of the OSI model, I really like this factory analogy. But yeah, if anyone has any comments about anything that I've missed or anything that I've got a little bit wrong, let me know, because obviously I am learning. I only started learning this since last week, so I'm just really trying to deepen my understanding, apply it to different kind of use cases. And I think this network factory analogy has allowed me to really start to picture it in my head. So I'm going to leave a few graphics that I've created below to just sum things up, which are kind of easy reference. And yeah, I hope someone finds this as useful as I've found making it to be. Thank you.